All right, we're given this triangle here and it says use Pythagorean theorem to find the unknown side, which means that, and give an exact answer and then a 2 decimal place approximation. Now the first thing that I do is I look for this right angle, because notice with the formula, what is opposite of the right angle is my C, and then I can call this leg B or even A if I want to, and say my unknown is B, because it doesn't really matter which one, which leg you call A or B. You can see typically if this was turned, and that's normally how you see it, that this probably would be A, but regardless. So I have A squared plus B squared equals C squared. I'm gonna let my A equal 10. So I'm going to solve. So basically I'm just solving for the other leg. I know 10 times 10 is 100. I know 20 times 20 is 400. Subtract 100 from both sides. And I get B squared equals 300. Now this is where you want to square root both sides, and we only care about the positive square root since this is a length. So I have to figure out how to break down this 300. And so what I kind of do is I go over here to the side and I think of, what two things can multiply to get 300, and just automatically I think 30 and 10, right? Because that's just something I can see with the zeros. And then I start breaking these down. So I think 30 could be 6 times 5. And then 2 times 3. So I'm breaking these down actually in prime numbers, and you'll kind of see the reason why. So B equals the square root of 2 times 3 times 5 times 2 times 5. And you could check this. You can multiply these out and make sure that works. Now remember, with a square root, when you have 2 of them, one of them can come out. Remember that? And so what's going to come out on the outside here, scroll down a little bit, is going to be, I have 2 5s, so 1 5 is going to come out, and 1 2, so 2 times 5. I'm only left with that 3, and that's going to give me 10 square roots of 3. So this is my exact answer. Then I can simply throw this in a calculator to get an approximate of 17.3.